Welcome everybody to week 6, day 3, lab time. This is not going to be publicly visible. It's just for my students. And what you are going to do in this homework assignment is you're going to do Bridges Severed Duck. Bridges Project 1 is what you guys are going to be working on. And what we have here is some demo code for you. For this assignment, it's part of an NSF grant. You guys get to be the guinea pig. Basically, you are going to have the option of doing one of 4 different assignments, 3 of which are ready. Mincarelli has been kind of working on the 4th, and I've looked at it. It's probably not going to happen. So you got really the option of 3 different things to do, and all 3 of them rely on this concept of a color grid. Okay, color grid is found inside of bridges.h. It is not part of the standard library. And what it is when you visualize a color grid, it creates a 10 by 10 set of squares, and each square could be given a different color. And so colors range from 0 to 255 in each of the 3 color channels, red, green, and blue. So if you guys have ever seen a color picker before, have you guys ever seen this before? Like a color picker? One of these things? You can adjust the hue and the brightness, and yeah. So you can enter it as like hue, saturation, but we're doing it in RGB. Okay, so if you have 0, 0, 0, that's black. Okay, and 25500 is red. The first channel is red. It ranges from 0 to 255. Second channel is green. Ranges from 0 to 255. Last channel is blue. Ranges from 0 to 255. And by combining these together, you can basically make any what we call 24-bit color. So there's 24 bits in every color. And so this here is a RGB value corresponding to no red, 100% green, and half blue. So if we put this into a color picker, we can see what kind of color we're going to get. No red, 255 green, and 128 blue gives you this kind of like greenish, tealish color. Okay, and we are going to draw this onto the color grid at row 4, column 2, row 5, column 2, row 6, column 2, row 7, column 2. It's going to draw a vertical line of that kind of teal color on a black background. So we've got a 10 by 10 grid, and it's going to draw a vertical line. Leave this alone. That's kind of the setup. Leave this alone. That's kind of the setup. Oh, except you're going to punch in your username and your API key. So the first thing you guys are going to do is you're going to go onto the Bridges website, which I will post again for you, bridges.uncc.github.io. You're going to log in. And when you log in, you're going to go to your profile, and the profile will give you your API key. That's your username. So I would put in my username here, and the API key, leave the quotes there. Whatever the API key is, you're going to put inside of the quotes there. That's the setup you have to do. Project ID, you can leave that as 1. But if you want to have multiple visualizations submitted to me, then when you're ready to move on to a new visualization, change this from 1 to a 2, 2 to a 3. Each of those numbers is like a save slot. And so if you like the one you got in slot 1, then, or you can change it to 30 or whatever. It doesn't really matter. And it won't overwrite it again. So I would just leave it at 1 to begin with. And then once you want to try and show off something new, then change that to a 2 or something. This is the title of your project. So for example, here we have regular pattern here. And this is the description. So whatever description you put inside of the string here will appear here. Okay. And this is what a grid looks like. This is a 20 by 20 grid. Every other one is white. This is what you have to do for one of the homework assignments if you want to get a C. Okay. So basically, this is like basically mocking SpongeBob. Okay. So this is one of the options. Basically, you've got here is, I think, the 15 by 15 grid. And every other one is pink and every other one is blue. All right. So if you could do mocking SpongeBob, you can probably do this. You're alternating blue then purple, blue then purple, blue then purple over and over again. And if you do this, you can probably get this done by the end of the lab today and get a C on the homework assignment. Yay. if you want to do the so okay, let me rewind. We'll get into the options in a second, but that's, you guys understand that's what a color grid is. A color grid creates a grid, and then you can set colors like this. So you say grid.set, the name of the variable is grid, it's of type color grid, and then this is how you can set one of those cells, 4 across, 2 down, whatever, 1, 2, 3, 4. Sorry, 4 down, 2 across. And then you can set that color to be teal, like this. What color is it setting it to? The value is held in red, green, and blue. You could just type these in directly if you wanted. So for example, if you wanted white, you could do 255, 255, 255. Right? Now note, this is very important in bridges. If you give a number that is outside of 0 to 255, this will crash your code. If you compile it, this is going to murder your code. And the error you get is not, hey, that number was outside of the range from 0 to 255. You're getting a terminate called after throwing an instance of stood : basic string, blah, 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 blah. When I got this last night, because I actually had a color outside of the range, I thought I had a problem with my strings. And so I'm like, well, the only strings I have here are here and here, so, let's comment those out. Nope, that wasn't the problem. The problem was I had a color that was outside the range. And, we've been talking a little bit about the philosophy of computer science. And one of the philosophies I follow is I will never allow my code to break, right? I vet my inputs. I don't trust any input, even if it's me. Even if it's a user I trust, I don't trust them. Every time somebody passes me a value, I'm like, is the value too big? Is the value too small? And if it is, then rather than exploding like this, then I'll print a error message like, hey, colors range from 0 to 255. Okay, so you can either pass the colors in directly like this, and the syntax is color open parentheses 255 255 255 for white, or 000 for black, or this is going to do yellow here. Pure red and pure green mixed together is yellow. So this is going to draw one square of yellow, and then on the row below it, do teal, teal, teal. 0, 0. Row 0 is the top row. Column 0 is the left column. All right. As Y goes up, it goes down. Row 0, row 1, row 2, row 3. Column 0, column 1, column 2, column 3, as it goes to the right. Okay. So what are your options? You're going to compile your code by typing make. Don't compile it using compile. You have to compile it using make, because you have to compile it in C++ 20 mode. Debugging has to be on. Actually, it doesn't. But you do need this. You need to compile it with the curl library. I think it might actually work with compile. But just type make to compile the code. It'll build it for you. So let's take a look at the README file. Okay, so the README file is going to give you the 3 options for this homework assignment. And you can pick now, or you can pick, like you can do lab time on one of them and be like, maybe I'll try a different one for the real thing. I'm not going to hold you to it. So the first, and there's demos of like all these things, right? So the first is calculating pi. So this one, this is a color grid, and it defaults to black, right? And so it's a 512 by 512 color grid. And 100,000 times, it's going to pick a random spot on the grid, and then it checks to see if the spot picked is within 256 of the center. Do you guys know how to compute the distance between 2 points? You pay attention in algebra. Pythagorean theorem. Hypot. You guys remember this? If you have x1, y1, x2, y2, you subtract the 2 and square it, you subtract the 2 and square it. Which one you subtract doesn't matter. first because you're squaring it. You're going to get a positive number either way. You square the result, and that will give you the distance between 2 points. Okay. So if you want to know if point 500, 300 is within 256 of the center point, 256, 256, you would subtract 256 from 500 and subtract 256 from 200, square each of those differences, add the results together, square root it. It'll give you a number. And if that number is within 256, then that point on this grid here, this is a grid, it's a very, if you zoom in, it is a 512 by 512 grid. If it's within 256, you draw a red dot there, and you have a variable that tracks how many hits you've gotten. You increment that by 1. If it is outside the radius of 256, then you draw a blue dot there, and basically you're just going to count how many red dots you've drawn, how many blue dots you've drawn. Okay, and then you're going to use the powers of algebra to estimate the value of pi from this, because there is a ratio of the area of a circle to the area of a square surrounding that circle. I think it's like pi over 4 or something like that. So basically you can count how many hits you got, how many misses you got, do a little bit of algebra, and then you're going to print to the screen here what value you have estimated of pi as the result. You can see here we're a little bit off. That's normal for 100,000 random dice rolls. So that's compute pi. Okay. A little bit of Euclidean distances. Hypot is the function that does this in C++. Next option is checkerboard. So the checkerboard, I was messing with this last night, and I'm like, this is too easy. This is too easy. This is the one I showed you earlier. Basically, you have a 15 by 15 color grid, and every other one is going to be either blue or purple. And Mancarelli's like, yeah, they're going to get bored. We don't want to make it too easy on them. So if you do this, you will get a C. The good news is it's very easy to do. Like, you could easily have this done by the end of lab time today. It's literally mocking SpongeBob. Every other one is either blue or purple, and you're done. But I wanted students to reach a little bit beyond the simple. And so if you do this one and nothing else, you get a C. If you do this one and this one, you get a B. Okay. Now this one is a 5 by 5 grid, and it looks pretty, right? Mm-hmm. What's happening here is we are lerping from, and I'll explain what that means in a second. We're lerping from no blue to 100% blue here, and we're lerping from no green to 100% green down here, and then they're mixing together over here as well. So what is lerp? Okay, so lerping is when you go out into the woods and you pretend to be wizards. Okay, so for example, I pause the recording here so I don't get copyright struck. Yeah, let's start the recording again. So we're not actually LARPing, we are lerping. Lerping, it's slightly different. So linear interpolation means given 2 points and a value t that ranges from 0 to 1 usually. If you pass in 0, you get the first point. If you pass in 1, you get the second point. If you want to think of like a car thermostat kind of thing. Let's see if we have a picture of it. Temperature dial. That is not what it looks like on my car. Just give me a little Nissan. Yeah, like this. Okay. All right. So you guys have seen these in cars. If you turn it all the way down, you get 60. If you turn it all the way up, you get 90. Okay, so what this dial is doing is lerping between 60 and 90. Okay? It goes lightning bolt, lightning bolt. I magic missile the darkness. Okay, no, wait, sorry. So if you turn the dial all the way down, then you're at 60 degrees. If you turn the dial all the way up, you're at 90 degrees. So what is it going to be? What temperature is it going to be at if you have the dial halfway between cold and hot? What do you guys think? So if you pass in 0.5, right? What are you going to get if the minimum value is 60, the highest value is 90? you're going to get the average, which is 60 plus 90, 150 divided by 2 is 75, right? So, yeah, so if you have the dial in the middle, it's 75. And so this is a lerp, okay? It's a linear interpolation. What are you lerping here? You're lerping the blue value. So the blue value will lerp from 0 to 255, right? The function looks like this, and x equals lerp from 0 to 255, and if you pass in like 0.5 here, what value is x going to have? This is the minimum value, 0. 255 is the maximum value, and 0.5 means halfway between them. So what value is x going to have here? What do you guys think? 75? What is halfway between 0 and 255? 128 or 127, because you're probably going to round down. So, how do you find out how far you are to the right? Well, you're going to have a doubly nested for loop, right? Anytime you see a square pattern like this, there's probably going to be a for loop saying for every row, for every column. And so whatever your loop counter is, like I and j, whatever you have for the row, you can just divide the row by however many rows you have. And that's the percentage down you are. And so at 0, you get, at 0 rows down, you're going to get 0. It's going to look something like this, right? It's going to be like your current row divided by max rows or whatever that is. You know, you might need to cast it to double, so you get a double instead of an integer. It's going to be something like that, right? Inside of your doubly nested for loop. I'm not writing your code for you, but it's going to look something like that. So as you go down the rows, this will go from 0 to 1. And you might have an off by 1 error also. Like if max rows is 10, then the highest I can be is 9, right? So you might have to subtract 1 or something like that. And so then that will be like your green, x would be like your green value here as you go down the rows. And then you do something similar for columns. As you go across the columns, you will lerp between 0 and 255 in blue. And you still have to maintain the checkerboard pattern so that every other one is white. And there you go. That's, if you do this and the other one, this is a beat. And you should probably will have that done by the end of class today. This is the one you choose. Now the next one will take a little bit more work because there is another lerp. It's pretty though, isn't it? I like it. I was pleased with myself last night. I wrote the first two last night, and then I typed make clean, which normally in a make file will just erase your executable and object files and core dump files and things like that. And the make clean erased my source code file. Bravo, well done. Whoever wrote that make file is a monster. I'm kidding. It's just a technical glitch, but it still erased my source code that I had finished, and so I redid it. And this one adds red, and the amount of red that it adds is based on, I think it's like you get full red up here and no red down here. So I guess it's like how close you are to the corner, I guess. So you get purple over here, you get blue over here, you get green over here. But it's pretty, isn't it? Like it's a pretty visualization, you know. And that's one of the cool things about bridges is that you can actually see your results, you know. It's nice. And then I did the same thing for the last one. I just changed the grid size from 20. The previous one, this one is 20 by 20. And then I upped it to 512 by 512. And then you got this really pretty, like, yeah, picture, basically. It's like a halftone where every other point is white. Okay. It's kind of a cool little image here. Okay. And this one and the previous one are literally the same code. All I changed was the grid size from 20 by 20 to 512 by 512. All right, so that is your second option. Lerp, by the way, is part of CMath. So if you want that, you have to hashtag include CMath, like that. And it's part of C++20. And so if you have a background compiler running in C++ 17 mode, which mine is, it it might complain about it. Now this is, yeah, there's no I, there's no max rows. But if it can't find lerp, that's because your background compiler is not running in C++20. But if you compile it, it will compile using the makefile. It will compile your code using C++20 mode. Lerp does exist there. Okay. So the third option is square fill. And this one is arguably the hardest, arguably not. I don't know. It's maybe the easiest to get an A in, but it's the hardest to do. I don't know. It depends on your perspective. So this one, and by the way, if you guys want to know how to copy and paste in Putty, if you just select something, it'll copy it automatically. If you're an NVim, because it eats your mouse click, that doesn't copy to the clipboard. So what you have to do is you have to hold down Shift and click. Okay. Makes sense? So, and then you can just come up here and hit paste. So this one is filling the color space with squares. Okay. And so what it does is it picks a random location and it draws a square there of size 1 by 1. In other words, a pixel, a point. And then then it draws a 3 by 3, then it draws a 5 by 5, then it draws a 7 by 7, it draws a 9 by 9, each time picking a random color. And it keeps doing this until it hits the edge of the world. Or until it hits another square. So if this square was here already, it would go bigger, 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 bigger. Oh, it's not black. Done. Okay. And then it just will pick another random point and go bigger, 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 until in this case it hit the bottom edge. Okay, bigger, 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 it hit this one. And so for this one, you would want to write a function that will draw a square to the screen. Okay. And, starting at this row, this column, going this many to the right, this many down, that's a for loop. And just fill the color grid with colors. Fill it with whatever color you pick randomly, probably. And you might want to have another function that will check to see if an area has anything in it already. And if it does, you just stop. And that's maybe not too bad. It's maybe bad. I don't know. It might hurt your brain a little bit, or you might enjoy it. Like the first person to finish, actually in the previous class, was a person who did this one. So you just pick random points and you do it over and over again until the image kind of gets filled. You might see there's still a few black points in here that aren't filled. But, these are just 1 by 1s because they're touching other things. Then the final option is called Bug Stomp. It's not ready and probably won't be. We were kind of going over it in the previous class. And it requires too much advanced C++ knowledge. So basically just pick one of these three. Okay? So if you guys can all post onto chat, I'm just kind of curious, which one of these three are you guys going to go after right now in lab time? You're going to do the calculate pi, where you're throwing darts at a dartboard and coloring it red if it's within the radius, coloring it blue if it's not, and then doing a ratio of reds to blues. Checkerboard, where you're generating these cool patterns. Checkerboard definitely has the lowest bar to success if you're just trying to get a C and bailing out. But you got to do it at least 3 times. They're slightly different. They're not very different. They're just slightly different. But you have to do it 3 times in order to get an A. And then square fill. You can probably get it done very quickly if you know what you're doing, but it can hurt your brain, like as you're growing these squares and stopping if it ever hits something. So here is Mincarelli's beautiful circle, which looks like I don't know if that's a circle or not. Kind of is. I mean, if you're on a grid, it probably actually is. Basically, you're gonna just randomly pick a row and a column, and then do a high pot to see if it's within the radius of the circle, and if it is, red. If not, blue. And then record it. Just write it down, which one you got. Okay. One thing you'll need for this, because the description is a string, and you want to you do something like this. So this converts a floating point number to string, converts a floating point number into a string, and then if you want to like add that, it's like if you're like I computed pi to be this, that's how you could like take a floating point number and add that floating point number to the output. So you'll need that for the compute pi one. Okay, Pyre checkers. Square fill seems cool. It is cool. 3 maybe. So it looks like we got a good mix. So that is it for my lecture for now. Mick Curley and I are here to offer you assistance. Remember, the first step is getting your username and your API key put in. The API key, even though it's a number, it goes within double quotes. Okay, because it's bigger than I think an int can hold. So make sure the API key still has the double quotes around. It takes a string, not an integer. Okay, begin.